Session. I'm Martin, I will be chairing the session, and at the same time I will be the third speaker. So we have three topics here that somehow have to do with several people doing something together, teams that matters. The first speaker, Eli, right? Yeah. Okay. They are doing something very interesting with models in the cloud, right? Then we have group model building things, and then something that has to do with mental models. So figure out what is the common thread amongst the three. So please, Ivan.
Okay, so hello everyone. My name is Ivan Pearl, and so if you hear me well, I think I don't need to use this device. So yeah, okay, great. So our work is related to it's called sdCloud, and yeah, we're really doing some interesting stuff in a cloud with the models. So first of all, some background that system dynamics is something that started more than 50 years ago and doing different things, different methodologies, different languages and other stuff. And for the last 50, 60 years, it was constantly evolving along with the tools which are used for it. And the important part here is that recently, for example, past maybe 5-10 years, we can see that we have more and more tools which are working around the system dynamics. So not just only we want to design a model, run a model, and get the results. We have a lot of things where we want to use models as a kind of piece which we want to integrate into other different systems, in IT systems, to deliver better experience, not only to the modelers, but also to bring modeling experience to the people who are actually not modelers, but they want to have modeling results. So what basically can we do in a cloud with models? I think the most obvious cases is that, for example, we can upload them to the cloud and share with other people because we did some work, we want to share it and show the results, and for example, to avoid reinventing the wheel and so on. So first we can just upload it and share it. Another step is that we can execute these models. That's also a very interesting case because to execute models we need resources, we need special tools, we need time to wait until the execution will be completed and so on. So to avoid this, we can just push it into the cloud and just watch for the progress. So when it will be done, we can track it from the phone, from the tablet, or whatever, get notifications and so on. And the third part is we can share the execution results. And it's also very interesting, and it's the most interesting part to share because we did some work, we did the research, and for example, what we have here in the poster presentations, we are sharing our results, what we achieved with the models. And this also can be easily achieved in the cloud because you have all the results in one place and they are acceptable and accessible worldwide. And so this is what is cloud for. But let's dive a bit deeper to look what exactly we are doing and how we are doing this. First, we are doing the two key directions. First, as I already said, is the model execution. So running the models, getting the results, and so on. So when we're doing it in the cloud, we can do it for a specific environment, for specific technologies, and that is why we have a wide range of approaches to make it optimal, to optimize execution, optimize storages, optimize resources utilization, so we can do it more efficiently than, for example, using different technologies, different machines. And another interesting thing is that we have plenty of tools developed around the system dynamics, and a lot of tools are actually open source, which is located in a GitHub, on the Code in a Bitbucket, and only small groups of people know about that we have this particular tool or that. So to bring better experience to everyone, why not to just put all these tools in one single place? So when someone will come to our cloud solution, he will just see, okay, so we have this amount of different open source tools, so I can apply to my model, for example, this analytics, or I can see what will happen if I'll try to analyze my model with these tools or with that, so which suggestions or proposals I will get from this. And another interesting thing is that so when you want to use an open source, in most cases you just need to download it, compile it with a special tool chain, Java, C++, maybe you need Node.js for JavaScript and so on. So if we have everything on the same cloud platform, it means that we already do special containers and we already did all this job. So now you can just step up and just take the results and use these tools. I think both the users of these tools and also developers of these tools are both interested in this because we are kind of connecting the consumers with the producers. So, okay, So let's talk a bit about the model execution. So the first thing, to execute a model, we need to take model from somewhere, and we already talked about it. Okay, so we can take a model from file. We can just upload it to the cloud. It will be just somehow chewed by the cloud, and we can do something else. But this is not the only scenario. At this moment, we see that we have several libraries of the models which are just growing all around. So, for example, on the GitHub, we have special repos with the models. I know about a couple of repos with specific models on the GitHub and on the Bitbucket and so on. So, why not allow user Okay, so also will allow users to just reference the models located in some other repos. So you don't need to just upload it. You can keep your repo with your models, and you can reference from the cloud service. You can reference models in your own repository. So when the model is, I think I will sit here. Okay, so some time ago, at the end of 2014, we get a great thing which is called XMile. So a unified way to store our model, so in a kind of unified way, unified format. And a lot of development is going around XMile right now. The community really supports this idea. And for our cloud, we also support this idea because mainly we are working with the XMile format. But not all the models which we currently have on the market are really XMile. So we have Dynamo, we have Vensim, we have Stellar, a lot of formats. To do this, we integrate one more piece to our system. So the next one, yeah. Last year on the System Dynamics conference, we introduced the sdCloud, SD Exchange project. It's a standalone translator for the models from one format to another. So at this moment, not many formats are supported, like Dynamo, Stella, XMile, but you can transport the models from one format to another. And this enables us to use, for example, Dynamo and Stella, translate it to XMile, and just move forward. So the next thing is the execution core and execution. So yeah, and you can just one more. At this moment, our solution is based on two key execution environments. First, the environment which is called PySD. Thanks for this. The idea of this system is that we can translate the XMile models into the Python and execute the real Python executable code. So we get kind of runnable model. Another thing we're working internally is kind of a replica of the Python, but for the Erlang. Erlang is very highly performant language, and it really suits well needs of the system dynamics. If we will look at the semantics of XMile, we will see that the model in XMile looks like a functional program, not an object-oriented. And most of the languages right now are object-oriented, but the Erlang is a pure functional language. So it's easier to map the models to the Erlang. Also, we're designing the system in a way that we can add any other execution engine. So we can extend the range of the runtimes which we are using in the cloud. So just with new items. For example, theoretically, we can even have SD everywhere, which translates from the XMile to C code also on board of sdCloud, and provide the end user an option which runtime environment they want to use for their particular needs. So after that, we just generate the results somewhere. Yeah, and we get the model execution results which we can deliver back to the end users. So moving forward, at a glance, we can find several things. First, we can absorb models which are just loaded directly. Well, okay. We can absorb models which are spread all around the internet and stored in the public repositories and already developed and already present in the market, and these libraries are supported by different communities. And also we can absorb open source tools which are developed for the needs of system dynamics, and we can just put them all together in one big system to provide easy access both to the models, to the tools, and to the execution environment. But what it's for? On the top of the system, we have well-defined REST APIs which allow you to integrate this solution to the solution which is required for a particular business. Because if we have models, that's awesome. If we have a good execution environment, we're also good. That's fine. But the real value which we're trying, it's application of these models. Because if we have a model and we can calculate it, compute, and maybe build some charts, but without a real application, it's useless. And to provide end users access to it, we're introducing also the web UI. But that's not the only thing which we are doing. The key thing for us is, our key focus is the REST API. So, the typical scenario of model usage and modeling usage is just uploading or choosing the model from the repository. Then it doesn't work. Yeah?
I started to.
Oh, okay. So, defining the execution parameters, because we can vary a lot of different parameters depending on the particular model we want to execute. And after that, we're just executing it in the cloud. And when execution is completed, we get execution results. The key point here is that we are spending a lot of efforts, because in our university we have good expertise in the parallel computation and high-scale computation and all this complicated math stuff, optimization of it. So these dots in the middle is our main focus, because we are trying to achieve the maximum performance of the execution to make this system really responsive, at least not on extremely complicated models. Sure, we always can build a model which will execute in several days, and even if we will have extremely high performances, still will be a very long period of time. But yeah, when we wanted to integrate it somewhere from the REST API perspective, we can integrate it into our web UI, and it's more or less reasonable because we are delivering the full stack. But also we can do, for example, this API access from the standalone application. So we have a real customer for whom we deliver some solution which is based on the model internally, and we really want to focus on the UI on this application, which will be really used by the customer and so on the customer side. We're just uploading the model to the sdCloud, and using the REST API, this application will just perform all the steps. It will, or it just will select the model and pushing different execution parameters, getting the results, and show the fancy charts. The same can be done with the mobile apps. For example, different applications for our phones, tablets, and so on. And at the bottom we have, third-party solutions. Because, for example, we are working, for example, on solving the traffic problems, and so we have a well-defined model for it. We want to upload somewhere and have different fancy applications to see the result of the modeling. So, for example, we want to tweak the settings of the traffic lights and so on. So before making any changes, this application, actually the purpose of the application is controlling the traffic lights, but we want to predict how the behavior of the traffic will change when we will change the parameters of it. And in this case, we will just use the model which is in sdCloud to build a prediction, and application itself will do its own job. It will really control the traffic lights and so on. I think that was one. Okay. And one more. Yeah. Okay, so there are a set of very popular in the cloud world paradigms. For example, DBAS. I think some of us at least know it. It's a database as a service. It means that we are very lazy and we don't want to deal with the database configuration, database administration, and support. We're just purchasing the database as a service, which is installed somewhere. We don't know how it's maintained. We just setting up how it works. And we're using it. We're developing our own application without interacting with the database. Next was introduced the platform as a service. So there is a big, complicated solution. We don't want to deploy it. We don't want to maintain it, but we really want to use it. So we want to build our solution on top of it. And this is a platform as a service, because platform is delivered to us already installed and maintained. The next one is software as a service. When we have a lot of small pieces like mail application and online chat, and so on. So it's just delivered to us as is, already as running application. So software as a service. And with our solution, with the sdCloud, we are trying to introduce the new paradigm, which is called MaaS, which is which is modeling as a service. So to keep the modeling far from the real business applications. So business applications do their own job, relying on the model execution service. So this is what we're trying to achieve, and this is what sdCloud is about. Yeah, we have just a couple more slides here. One is with my photo from previous SD conference. Just yeah. And yeah, that's it.
Okay.
Thank you so much for your attention. And